Hello and welcome to the Daily Space for today, Thursday, June 28th, 2018. I am your host, Dr. Pamela Gay, and today I'm going to bring you a quick roundup of, some of what's new in space and astronomy. Yesterday, you heard the news that the James Webb Space Telescope is going to be delayed yet one more year. We are currently looking at a March 2021 launch date. It is currently unclear exactly what ramifications this will have across NASA and across other spacecraft that are, on the ground and hoping to go into space not too far in the future. The issue here is one of budget. The James Webb Space Telescope was slated to have a total expense prior to launch of no more than $8 billion. It was capped solid at $8 billion. NASA is currently projecting out that in order to launch in March 2021, the total cost will need to rise to $8.9 billion, which means they have to come up with almost $1 billion on a budget that's just not that high. So now comes the question of where is NASA going to find the money? Is Congress going to let them have it? And do we get to have our spacecraft? That, unfortunately, is all I know on the James Webb Space Telescope. I do know that folks at WFIRST and other missions are very closely watching the NASA astrophysics budget as it works its way through the Senate and the House towards hopefully getting voted on in the not too distant future. So this is one of those times where your space future lies in the hands of those in Congress. Sorry, Canadians. Americans, it's on us. So that was the piece of news that I know most of you have been most thoughtful about. But looking toward happier things, we have a cute diamond-shaped rock. This particular rock, which is named Ryugu, is about 1 kilometer across, and the Hayabusa 2 spacecraft has just rendezvoused with this little diamond-shaped rock and is going to be shooting it with a projectile. This isn't too different from what we're waiting for OSIRIS-REx to do. They're going to be shooting this little asteroid with a projectile, grabbing a fresh sample of soil from beneath its surface, and bringing that sample back to Earth. So one of the reasons we have a small rock is, small rocks are easier to grab, stuff from. So here is to one successful mission that launched back in 2014, has now rendezvoused with its rock, and hopefully will be bringing us back more science to work on in the not too distant future. Now, one of the things that I particularly love about this particular rock and many other rocks in space is they're covered with smaller rocks. It is indeed rocks all the way down. Looking at this particular image, you can see that it does have some enclaves in it that are reminiscent of well-worn craters. Well, in this case, well-worn could mean that this is something of a rubble pile, and the rocks sitting on its surface are just echoes of what it is all the way throughout, with dust and rocks loosely bound together by gravity. These are some of the most common objects out there, and trying to figure out if asteroids are rubble piles or solid objects is one of those things that we really want to know. It's unclear if this particular mission will help answer that particular question, but it does give us one more cool rubble pile to look at. The last set of data we got from an object like this came from Itakawa, which also had this covered in boulders, covered in rocks kind of look and feel to it. So moving from one rock to one former rock, we have an update on the Umeameya alien object that entered our solar system last September. This particular object is on a special kind of what we call parabolic orbit. This is an orbit that has it coming in, circling around the sun, but not a complete circle, just kind of making a 180, and then heading back out the other direction. And as this object exits our solar system. We unfortunately weren't able to get the best of the best views of it, but we've taken what we can. This object was actually detected, or actually it's on your screen over there. This object was actually detected after it made its closest approach to the planet Earth. Once detected, however, we have thrown all our astronomical resources we can at it. We have determined it is weird shaped. It is also gaining velocity in ways that we just hadn't expected from an everyday rock. Scientists studying this object with the Hubble Space Telescope have determined that in all likelihood, it is not an asteroid, it is not a spaceship, it is in fact a comet or some sort of comet asteroid conglomeration that has enough volatiles that outgassing due to solar radiation heating the object up has actually accelerated it on its path. So here is to awesome alien invaders that do no harm and offer many, many questions. I see there's some questions in the chat. I'll get to all of your questions in just a moment. So in our final story for today, we have a new feel for what the dust is in other galaxies. And the result is you shouldn't wash your galaxies down the drain unless you run a lot of hot water afterwards. This is because a group of scientists working to understand, and this is work done and published by the Royal Astronomical Society. This is a team at UNSW. This is the University of New South Wales in Australia. They have taken a look at what is gas and dust in other galaxies made of, and they have worked to recreate this gas and dust in their laboratory. And what they found is it pretty much has the characteristics of being greasy. So this is not something that you'd normally expect to be saying about space, but it turns out that all of these organic molecules that we knew were out there, that we've been studying for a long time, if you actually get a little up close and personal, they're kind of gross, or at least things that you'd scrub out of your sink. So this is new and interesting ways of looking at it. So the particular process that they studied was they looked at organic molecules, such as those that are created in carbon stars. These are stars that have enhanced carbon in their atmosphere, and they shed it out in the form of dust. When you recreate that material, you get grease. Not all science is sexy, but some of it is just plain awesome nonetheless. So from rubble piles with spacecraft visiting to alien comets visiting us to grease in other galaxies, that was today's news. And now I will go ahead and take your questions. I did see that there was a question already in the chat asking if the European Space Agency had contributed to the James Webb Space Telescope. I know that the James Webb Space Telescope is a multi-international collaboration. I don't know in what degree different nations have contributed to it. Often the way different nations contribute to a spacecraft is they provide specific instrumentation. So for instance, they might provide a camera, a radio antenna. Canada likes to provide various robotic arms. So in this case, it's not that the budget is being contributed to by another nation, but rather another nation is saying, hi, we have completed this thing that you just need to slide into your spacecraft and it's ready to launch. In this case, James Webb Space Telescope, as is being pointed out, is supposed to launch in an Ariane 5 that will launch from French New Guinea. It was during the integration tests with the rocket that they've actually found a number of different problems. The integration testing was going on out in California, and they had previously found some other issues they needed to fix as well. The entire independent review report is available on the internet, and if you'd like a long read on just how complicated it is to create, test, and launch something that has never been done before. And the complexities of letting astronomers figure out how to do this rather than business managers, I'd recommend giving it a read. So I see Silent Searchlight is commenting French Guinea, South America, New Guinea. Oh, yes, I meant to say French Guinea. I said French New Guinea, which is not a place. French Guiana, which is in South America. Thank you so much for the correction. So Farron H is saying, if an asteroid was mostly solid, would we expect that it broke off of a larger body? Not necessarily. The way that asteroids, planets, and in fact most objects in our solar system formed was that during the early solar nebula period, that time during our solar system where we were going from a giant blob of gas and dust to being a star and discrete fairly solid objects. We had initially dust particles glomming together, and then larger and larger dust particles glommed together until they formed what were called planetesimals. In some cases, these planetesimals were on orbits that allowed them to gravitationally get pulled in close with other planetesimals and build in size. And as their gravity grew, they were able to grab more things, and they continued to grow in size. But while many objects, many of these planetesimals, were able to go on to become the 8 planets we know about, the asteroid belt, the Kuiper belt, and perhaps a 9th planet out in the outer solar system, not all objects, as you can clearly see, came out the same size. In some cases, planetesimals kind of stopped, and now we call them asteroids. Now we call them small comets because they never built up to be big enough to be more than just an asteroid. So often what we're seeing with asteroids is just an object exactly the way it came into existence. Yes, the silent searchlight, you're right, the Oort cloud's out there as well. Now, one caveat on that is asteroids do sometimes smack each other around, and we did have in our solar system's history a period called the Great Heavy Bombardment. This was a period during which the interactions of Jupiter and Saturn, which were in very different orbits, were able to fling using gravity and resonances, debris all over the solar system. Some rocks got thrown out, some rocks got thrown inwards where they hit the Earth, Moon, Mars, Mercury, and these are the events that shaped our worlds and brought us our oceans here on Earth. And during the same period of heavy bombardment, some of the asteroids actually, well, collided into one another. This is how we're able to find Vesta asteroids here on Earth, Vesta meteorites here on Earth. The Vesta asteroid was hit at some point in its past. Debris was thrown up, and some of that debris was tossed into orbits that would cause it to later collide with our own planet, allowing us to get samples of Vesta without having to actually go to Vesta and bring things back. So I see Hanny is saying, would the finding of Planet 9 prove the pinball solar system creation idea, or is the rough beginning pretty well established? I think a lot of people would say the rough beginning is pretty well established, this idea of the Great Heavy Bombardment. Exactly how it got to be at the most detailed levels is still indeed up for debate. We have some scientists who say that if you do 3D modeling, you don't actually need to have as much gravitational interaction as the NEAS model predicts, whereas there are others who believe the current models just need nuances added. Finding a Planet 9 will open as many questions as it solves. It will answer, why do we see all of these Kuiper Belt objects on such odd orbits? Why is Sedna, which may be a inner Oort cloud object, in such a weird orbit? It will help us understand that. But as to whether or not it's something we stole from another solar system when we were in a denser part of our solar system's existence, or whether it is something that came from the inner solar system and migrated outwards, that one may be a little bit harder to answer. So I'm looking to see if there's any other questions out there. Yeah, our sun could be a thief. It's looking more and more like thousands to tens of thousands of objects that visit our solar system on a regular basis or are already in our solar system and trapped here to stay may be things that either visited or were wrenched gravitationally from other solar systems. So that rock you're looking on may not necessarily be a native rock. Immigration is something that happens everywhere. So looking to see what else there are in the questions. So while you type in any questions you have, we will not be having a Learning Space episode today. Normally we do have those on Thursdays. This is actually the last week of the season for both the Weekly Space Hangout, which is, it had its last episode last night, and tomorrow will be our last episode of the season of Astronomy Cast. Astronomy Cast is filmed over on YouTube. Go to astronomycast.com to find out all the details on how you can tune in to tomorrow's live final episode of the season recording. Tonight is an open night, so go find a place to get science, or, well, go check out the Astronomy Cast 500th episode tour and plan how you can make a weekend of science in the fall. Astronomy Cast, which is another program produced by the Astronomical Society of the Pacific, the home organization of the Daily Space, is a long-running podcast that I co-host with Universe Today's Fraser Kane, and we're doing a live recording here in Edwardsville, Illinois on the weekend of September 15th and 16th. You can reserve your spot by clicking on the Trips tab at astronomycast.com. So looking at the question, Hannes Vorwerp is saying, do we see evidence of bombardment in other solar systems? We don't have enough details yet to be able to answer those kinds of questions. We're able to understand the period of heavy bombardment in our own solar system by looking at the cratering record on other worlds. When we look to the moon, when we look to Mars and Mercury, we can tell due to volcanism, due to massive impacts that erased large segments of the world, that there was a time in the past where there was a lot more cratering happening than there is today. By going through and trying to figure out what things lie on top of other things and have erased, well, the historic record from the surface of all of these worlds, we've been able to build up a dynamic picture of the rate of cratering on many different planets and our own Earth's moon. By putting all of these different things together, we've come to understand that about 3.5 billion years ago, our solar system was a place of violence where rocks fell from the skies, pretty much any sky you happen to be talking about. Now, I see people in the chat pointing out that speaking of craters, you can actually help CosmoQuest map out other worlds. Now, I've been saying this for about a month now, and yesterday I pulled our statistics, and you guys are not helping us, at least not as much as you did in April. So I would ask all of you to go out and spend a few minutes, map Mars, map Mercury. These are the places we most need your help, and every mark you make really helps our project out as we work to map out these other worlds. So I'm not seeing any more questions. I'm going to keep today short and sweet since our news is short and sweet. I already have seen some pretty amazing stories under embargo for tomorrow, and I can't wait to be able to bring you tomorrow's news. So stay tuned. And tomorrow at 1 p.m. Eastern, 6 p.m. London, 10 a.m. Pacific, I will be back bringing you a new update of space and astronomy. Um, uh, yes to your question, Silent Searchlight. Um, so that's it. That's all I've got for today. So wherever you may be in the world, well, let me first do all of the credits. The Daily Space is brought to you by folks across many different institutions. I'm Dr. Pamela Gay, and along with Dr. Andreas Plazas, I work for the Astronomical Society of the Pacific. We also have streaming on this channel Dr. Matt Richardson of the Planetary Science Institute, and Annie Wilson brings you Science Sundays from Youngstown State University. Our collaboration is run out of the Astronomical Society of the Pacific, a 501c3 nonprofit. If you want to keep up with all the content we're creating, give our channel a follow. If you want to sustain our efforts, please consider a subscription, and every bit always counts. So thank you, and I look forward to seeing you tomorrow and sharing all of the cool and awesome embargoed news with you then. For now, remember to have a fabulous morning, evening, or afternoon, wherever in the world you may be, and take a moment to look up. Bye-bye.